Good evening, children.
Good evening,
Good
ma'am.
evening, ma'am.
Good
Good
evening.
evening, ma'am.
Good evening, children. I've shared my screen. Is it visible?
Yes, ma'am.
Yes, ma'am.
Very good. Very nice. Yeah. Okay. So this is cubes and cube roots. Uh, we have not actually completed the chapter squares and square roots. So we have some more patterns to understand from the same chapter, squares and square roots. I'll do some part of cubes and cube roots today, and then we'll see the patterns in the chapter squares and square roots and cubes and cube roots, all together. All right. We have some interesting patterns in the chapter squares and square roots. We have the same in this chapter cubes and cube roots also. We have some interesting patterns in this chapter cubes and cube roots too. So we'll see the patterns of both the chapters, together, all together. The rest of cubes and cube roots I want to complete. So that's what we are going to do in today's session. All right. So consider the mathematical equation 4 into 4 into 4 equals 64. Here, 64 is said to be the cube of 4 and 4 is said to be the cube root of 64. The symbol, what you see here, is read as the cube root of, Symbolically, 4 cubed is equal to 64 and the cube root of 64 is 4. Just a minute.
Ma'am, we have to copy this, ma'am.
Yeah, I'll tell you. Just a minute. I'll read through the slide again. Consider the mathematical equation 4 into 4 into 4. So 4 is multiplied with itself and then by itself again. 4 is multiplied by itself and then by itself again. All right. So 4 into 4 into 4 is equal to 64. This is a mathematical equation. It's an equation. You can see the equal to sign. It's an equation. All right. So in this equation, 64 is said to be the cube of 4. 64 is said to be the cube of 4. And 4 is said to be the cube root of 64. All right. The symbol, what you see here, is read as, the cube root of. The cube root of. This symbol is read as the cube root of. So if there's a number 8 here, the cube root of 8. The cube root of 8. Symbolically, for this mathematical equation, symbolically, 4 cubed is equal to 64. 4 into 4 into 4 means 4 cubed. 4 cubed is equal to 64. 4 into 4 into 4 is written as 4 to the power 3. We have understood this in exponents last year. Okay, repeated multiplication can be written in the exponential form. Repeated multiplication can be written in the exponential form. For example, 5 into 5 into 5 into 5, 25 times. 25 times is written as 5 raised to the power 25. Repeated addition is multiplication. Repeated multiplication is written in the exponential form. I'll just tell you, see here. Repeated addition is multiplication. See, if you have 5 into 5, sorry. 5 plus 5 plus 5 plus 5 plus 5 like this 25 times. This is repeated addition. Repeated addition. Repeated addition is multiplication. Repeated addition can be expressed as a product. Okay, let me write that. Repeated addition can be expressed as a product. Can be expressed as a product. So how do you express it as a product? 5 multiplied by 25. 5 plus 5 plus 5 plus 5 25 times can be written as 5 into 25. See, what is 5 plus 5 plus 5? 5 into 3 is equal to 5 into 3. What is 5 plus 5 plus 5 plus 5 plus 5 plus 5? 6 times, no? So 5 into 6. Because when you add, you get 30 and 5 into 6 is 30. So repeated addition can be expressed as a product 5 into 6 or 5 into 3 accordingly. So here in this example, it is 5 into 25. We know this. This is not new to us. We know this. Now, if it is repeated multiplication, then it's expressed in the exponential form. Repeated multiplication, like 5 into 5 into 5 into 5. So like this, it goes on 25 times. Okay. Now, this is repeated multiplication. Repeated multiplication can be expressed in the exponential form. And here it is 5 raised to the power 25. 5 into 5 into 5 into 5, 25 times is written as 5 raised to the power 25, where 5 is the number that is repeated. Okay, and 25 is the number of times it is repeated. 5 is the number, the base. This is called the base. You know it. You know this. You are familiar with the terms base and exponent or base and power. You can call the power, you can call it exponent, or you can also call it index. Index. All these three terms mean the same. It refers to this one. Base is, there's only one word, base. This is the base. So in this expression, 5 is the base and 25 is the power or the exponent or the index. That's why this chapter is called indices also. Indices, meaning exponents. Okay. So in repeated multiplication, the number that is repeated is the base, and the number of times it is multiplied by itself is the power. So how many times? 25 times. That's the power. What is repeated? The number 5 is multiplied by itself many times. So that number 5 becomes the base, and the number of times it is repeated becomes the power. So this is the exponential form. 5 raised to the power 25. 5 is the base. 25 is called the power, exponent, or index. Repeated multiplication is written in the exponential form. Repeated addition is multiplication or can be expressed as a product. So here it is repeated multiplication, right? 4 into 4 into 4, right? So 4 is the base, and the number of times it's multiplied with itself becomes the power. 1, 2, 3 times. So 3 is the power. How many times can you see 4? 3 times. You can see 4 3 times. So 3 is the power. So 4 cubed. This is 4 cubed. 4 into 4 into 4 is 4 cubed. Or 4 raised to the power 3 is equal to 64. And the cube root of 64 The cube root of 64 is 4. Are the contents of the slide understood?
Yes, ma'am.
Very good. Yeah. Now let's read this one. Cube of a number. The cube of a number is the, so we understood. Okay, we understood what the cube of a number is using an example here. Okay, now we'll see the definition. The cube of a number is the product of the number multiplied by itself and then itself again. Multiplied by itself and then itself again. The cube of a number is the product of a number, so some number, multiplied by itself and then itself again. Number multiplied by itself and then itself again. So this is the cube of a number. All right. So for example, the cube of 5 is 5 into 5 into 5, 125. Symbolically, meaning using symbols, 5 raised to the power 3 is equal to 125. Perfect cube or a cube number. A number said to be a perfect cube or a cube number, like perfect square, square number. Perfect square, square number. Both the terms mean the same. In the same way, perfect cube or cube number, both are the same. Perfect cube or cube number. Okay, so a number is said to be a perfect cube or a cube number if it is the cube of some other natural number. A similar definition is for a perfect square. A number is said to be a perfect square if it is the square of some other natural number. A number is said to be a perfect square if it is the square of some other natural number. Likewise, a number is said to be a perfect cube if it is the cube of some other natural number. Okay, so we'll understand the definition with an example. For example, 216 is a perfect cube or a cube number. 216 is a perfect cube or a cube number because it can be written as 6 raised to the power 3. Why do you call 216? Why do we call 216 a perfect cube or a cube number? Because it can be written as the cube, because it can be written as the cube of some other natural number. Two hundred and sixteen is a perfect cube or a cube number because by the definition, it can be written as a cube of some other natural number. It need not be some other natural number. It can be some natural number. Okay, it need not be other. I'll just remove that word other. Some natural number can be anything. If it can, if it is a cube of some natural number, you can just ignore this word other. I'll just correct it in the presentation later. All right. Okay. Yeah. So 216 is a perfect cube or a cube number as it can be written as 6 cubed, where 6 is a natural number. The cube of some natural number. Okay, so the cube of 6 is 216. So 216 is a perfect cube or a cube number. So you can here in this table see the cubes of natural numbers from 1 to 10. In this table, you can find the cubes of natural numbers from 1 to 10. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed 216, 7 cubed 343, 8 cubed 512, 9 cubed 729, 10 cubed is 1000. Let's check the ones digit or the unit digit in all these cubes. Okay, we'll search from 0. So see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we see that a cube number can end with any digit from 0 to 9. A cube number can end with any digit from 0 to 9. But what about for square numbers from 1 to 10? 1 is 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 6 are 36, 7 7s are 49, 8 8s are 64, 9 9s are 81, 10 into 10 is 100. So what are the digits we see here? 1 2 times. Okay, let's start from 0. 0 once, 1 2 times we have, 2 we don't have. There is no square number from 1 to 10 that ends with the digit 2. 3 also we don't have. 4 we have it 2 times. 5 we have it once. 6 we have it 2 times. 7 we don't have. We don't have 7 in the ones place of any square number from 1 to 10. 7 we don't have. 8 also we don't have. 9 we have it 2 times. So a square number can end with a digit, or the units place of a square number can end with 0, 1, not 2, 3, 4, 5, 6, not 7, 8, 9. So a perfect square can end with the digits 0, 1, 2, 3 not possible, 4, 5, 6, 7, 8 not possible, 9. So if you're given a number like 4, 4, 4, 9, 9, 9, 7, you can straight away say it is not a perfect square. It's not a perfect square because no perfect square ends with the digit 7. You don't have to find the square root and then comment if it is a perfect square or not, just by looking at the units place. Because no square number or no perfect square will end with the digit 2, 3, 7 or 8. So straight away we can say, or if this ends with 8, not a perfect square. It ends with 2, no, it's not a perfect square. It ends with 3, no, it's not a perfect square. Without any calculation, just by looking at the number, just by looking at the unit digit of the number, you can say if the number is a perfect square or not. But that doesn't mean if a number ends with the digit 0, 1, 4, 5, 6 or 9, if a number ends with one of these digits, it doesn't mean that that number is a perfect square. It may be a perfect square. You cannot say that it is a perfect square. If a number ends with the digit 4, a number ends with the digit 4. Now we know this is a perfect square, 8 into 8. Now what about 74? It's not a perfect square, but it ends with the digit 4. So all numbers that end with the digit 0, 1, 4, 5, 6 or 9 need not be a perfect square. They may be a perfect square, but they need not be a perfect square. There is no condition that it has to be a perfect square because it ends with 0, it ends with 1, it ends with 4, 5, 6 or 9. So it is a perfect square. No. It may be a perfect square. But if it ends with one of these digits, it is not a perfect square. Without any calculation, you can say that. Now, coming to a perfect cube or a cube number, we see that a cube number can end with any digit from 0 to 9. We have only digits from 0 to 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Only the units place of a number can hold one of these digits. Now, a perfect cube can end with any digit from 0 to 9. So just by looking at the number, you cannot say. Just by looking at the units place of the given number, we cannot say if it is a perfect cube or not, like in the case of a square number. That's a difference. Okay. So you can see here a cube number can end with any digit. End with, we are talking only about the units place, can end with. So we're talking about the units place here. It can end with any digit. Cube of a positive number is positive. Cube of a negative number is negative. Cube of a negative number is negative because -2 into -2 into -2. So now you understand cube of a number meaning multiply the number with itself and then itself again. So minus 2 cubed meaning minus 2 into minus 2 into minus 2. Minus into minus plus, plus into minus, minus. 2 2s are 4, 4 2s are 8. So we see that the cube of a negative number is negative. The cube of a positive number will be positive. So like 2 into 2 into 2. Positive number is positive, positive 8. So cube of a positive number is positive, cube of a negative number is negative. Because 3 times, no, minus happens 3 times. So it is, the product is negative. Cube numbers are related to volume of a cube. So when we take a question, it will be more clear to you, but just remember now, cube numbers are related to volume of a cube. Square numbers are related to area of a square. Square numbers, not area of rectangle. Square numbers like 4, 16, 25, 49, 64, 100. Square numbers, they are related to area of a square, not area of rectangle, area of a square. Square numbers are related to area of a square. So if you have a word problem, the area of the square is given and you have to find the side of the square, you should just find the square root of the given value, the area. Just to give you an example, I'll just take a decimal number. Okay, so supposing you're given that the area of a square is 6102.7344 meter square. Okay, the area of a square is 6102.7344 meters square. Find the side of the square. Find the side of the square. So you just have to find the square root of the area using the long division method. Whatever you get here is the side of the square. So perfect squares or square numbers are related to area of a square. So if you have a question like this, the area of a square field, is 6102.7344 meters square. Find the side of the field. So you just have to find the square root of the area value given. Okay, find the square root. So what you get here in the quotient is the side of the square field. Side of the square field. Once you find the side, you can even find the perimeter. 4 into A, 4 into side, right? So if you're given the area of the square field and asked to find the perimeter, you'll have to find the side and then find the perimeter. You cannot find perimeter straight away. From area, you cannot directly find perimeter. In between, you should find the side. So area is given, find the square root of the area value by the long division method. So what you get in the quotient is the side of the square field. Now you have the side. 4 into side will give you the perimeter. So that's what is meant by saying, what did I say? Yeah, square number or a perfect square is related to area of a square. Similarly here, cube numbers are related to volume of a cube. Cube numbers are related to volume of a cube. So if the volume of a cube is given, cube, okay, and volume of the cube is given, a cube is 3-dimensional, okay? It has length, it has breadth, it has height. And all the 3 values are the same in a cube. In a cube, the length is equal to the breadth is equal to the height. L is equal to B is equal to H in a cube. If you're given the value, of the volume of a cube, so like okay, so 91.125 centimeter cubed. This is the volume of a cube. Find the edge of the cube. Edge meaning the side, length, breadth, or height. Edge of the cube. Volume of cube is given to you, 91.125 centimeter cubed. Find the edge of the cube. So the cube root of volume will give you the side or the edge of the cube. Like square root of area will give you the side of the square. Square root of area will give you the side of the square. Cube root of volume will give you the edge of a cube.
Ma'am, could you repeat it? I didn't understand.
Really? Okay. This is a square. Side of the square is equal to square root of area. Cube is a cube. Edge of the cube is equal to cube root of volume. If you find the cube root of volume, you will find the edge of the cube. If you find the square root of area, you will find the side of the square. Don't worry too much. We'll take up a question. So we'll be visiting it, like 2-3 times, then it'll be okay. If it's still not okay, don't worry. Don't worry. When we take up a question, you can again ask me if you don't understand.
Okay, ma'am.
All right, children? Only this part, right, Sahasra?
Yes, ma'am.
Okay. Is it okay now or not at all okay?
It's okay, ma'am.
It's okay now. Yeah, that's okay. That's enough. For now, that's enough. Yeah, don't worry. Okay. So here I have tabulated what the cubes of natural numbers from 1 to 20. Okay. So you need to memorize them. The benefit of memorizing is like, see, if you have to find the cube root of 4913. Okay, now the cube root of 4913 is 17, and 17 is a prime number. You will be trying hard by 2, by 3, by 5, by 7. It's not divisible. It will not be divisible. 4913 is not divisible by 2, 3, 5, 7, 11, 13, and then you will be tired. Maybe you will give up. And you will not have very large numbers also, meaning you may have large numbers, but its cube root will not be a very large prime number, I'm saying. So it's enough if you remember the cubes of the first 20 natural numbers, as you see on your screen now. That's enough. So if you're asked to find the cube root of 4913, okay, so you have to straight away hit 17. It is 17 289 times, 17 times, and 17 ones are. So 4913 is 17 into 17 into 17. So the cube root of 4913 is 17. The cube of 17 is 4913. All right, children? So see, these are some important results like we saw in the chapter squares and square roots. I'll just give you some time, just have a look at them.
I'm finished, ma'am. Finished.
Oh, all right. All right. Yeah, answer this question. So leave from now you will start working, children. From now you will start working. You'll have to leave, some pages sufficient to write all these notes. So this one, this, this.
Ma'am, can you just say how many pages?
If you're using a long notebook, then 6 sides, because I'll be sharing the answers also to these questions.
Okay, ma'am. 6 pages. Okay, ma'am.
I'll be sharing the answers also to these questions. So you need 6 sides. Long notebook, six. Long notebook, 6 sides. Yeah.
Ma'am, okay, ma'am. Ma'am, from this find cube root of 11, this is the working part.
Yeah.
Part. Okay, ma'am.
Today's classwork. We'll be answering the questions. You'll be working out the answers in the class. The notes still here. I'll share on WhatsApp as usual.
Okay, ma'am.
You have to complete them. Today's classwork, writing work starts from now. So leave 6 sides in your long notebook and take down this question. You can write today's date. What's the date today? 26. Write today's date, 26/6/2014. Write the name of the chapter, cubes and cube roots. Question number 1. Always write the date before you start your work. Yeah. Find the cube of 11. So the cube of 11 means, see here, the cube of 11, like this. Did you see me write it? Did you see me write that? The cube of 11. So this is nothing but 11 into 11 into 11, which is 1331. Write down.
Finished, ma'am.
Done, ma'am.
Very good. Shri Harini, finish writing?
Ma'am, finished, ma'am.
Okay. Next question. The cube root of 10,648. Find the cube root of 10,648. Yes, all of you get started with the prime factorization of 10,648. I want it in the order. First write 2, finish 2. Then when you see it's not divisible by 2, then you should try 3. It's not divisible by 3, then 5, then 7. Start doing. I want the prime factors in order. Write the question. Please work. I'll just come back in a minute.
Finished, ma'am. Finished, ma'am. I'm done, ma'am.
Okay.
So
So
answer
two.
is 2 cube into 11 cube. Ma'am, answer is 2 into 11, 22. 22, ma'am.
Okay. So 10,648 divided by 2 is what? Tell me the number here.
Ma'am, 5,324.
Okay. 2 again.
2,662, ma'am.
2,662.
2,661. After that, 1,362. And then 1,331, ma'am. By 11, and then again 121 will come. 11, 121. And then 11 again. Yes, again, ma'am. And then 11 again. 11. And then 11 again. 11 again. And then 1. 1 cube into 11. 2. And then cube root of 1,648 is
No.
equal
Yeah.
to.
Thank you. From now, I'll continue. I'll continue from now. Thank you. Very good, all of you. From now, I'll continue. Please mute your mics. So now 10,648 is equal to 2 cubed into 11 cubed. You can also write 2 into 2 into 2 into 11 into 11 into 11. You can write that, but I think you should prefer to write it this way. Writing 2 into 2 into 2 into 11 into 11 to 11 is also correct. But you can save time, no? If you supposing have some 9 twos, right? So it takes a little longer time to write all that. Maybe you will miss out on a 2. So please use the exponential form like this. Now repeat the step and take a cube root on both the sides. Now check your book if you have forgotten to write this 3 here. Normally we forget to write. If you don't write this 3, that is square root. take cube root on both the sides. So you should write this 3 here. And some of us, carelessly will write 3 outside. Not outside, inside this part, inside this. It's not like this. This is different. This has a different meaning. Writing 3 here and putting the square root symbol. This has a different meaning. It's here, 3 here. So if you've forgotten or missed to write the 3, please put it now. So write that step, repeat that step and take cube root on both the sides. Now write this as it is, cube root of 10,648 as it is equal to. Now you'll have to get rid of the cube root symbol here on the right hand side. You have to get rid of the cube root symbol on the right hand side. So for that, from 3 equal prime factors, bring 1 out. From 3, this is cube root, no? So from 3 equal prime factors, bring 1 out. So we have 3 2s, 3 equal prime factors, no, 3 2s. So the prime factor is the same, 2 2 2. 3 equal prime factors, 2 2 2, 1 out. Similarly, 11 11 11, 1 11 out. So the cube root of 10,648 is equal to 22, which means 22 into 22 into 22 is 10,648. I'm sure you would have all done it correctly, but just check your steps. And as I told you, see if you missed to write this 3. Done, children?
Yes, ma'am.
Very good.
Yes, ma'am.
Yeah. This question is 13,824 a perfect cube? Give reasons. Again, get started. Write the question. Work the prime factorization of 13,824. Write the question first. Done with the prime factorization?
No, ma'am.
Okay. No hurry. Do it correctly. Okay, so 2 how many times?
Ma'am, 9 times.
9 times.
Yes, ma'am. 9 times. 6912 times. 6,912 times. 6912, ma'am. You put
Yeah.
a 9. Oh, ma'am, I thought you asked number of twos. Sorry. 6912.
Oh.
3456. 2. 1728. 1728. Then 864. And 432. The 2 table only. And then 432. And then 216. And then
No, 1 minute. 432.
Yes, ma'am. Yeah. Two table, 216. 216. And then 108. And then 54. And 3 table. 27, 3 table. And then 9, 3 table. And then 3 table. And then that's it, ma'am. Ma'am, the answer is 36, ma'am. 36 is the answer. Final answer. Cube.
So 13,824 is equal to 1, 2, 3, 1, 2, 3, 1, 2, 3.
So 2 raised to the power 9 into 3 cube.
Somebody's mic is enabled and I'm able to hear the noise from your background. Is it Harini? Shri Harini? Please disable your mic.
Yes, ma'am. Can I say now?
24. Yeah. No. Thank you. No. I just wanted the factorization part, children.
24.
Yeah. Thank you. I'll continue. So 13,824 is equal to 2 to the power 3 into 2 to the power 3 into 2 to the power 3 into 3 to the power 3. You can also write 2 to the power 9. That's not wrong. You can also write 2 to the power 9. Okay, so 13,824 is equal to 2 cubed into 2 cubed into 2 cubed into 3 cubed. I'm writing the primes raised to the power 3. Now repeat the step. Write the step again. And take cube root on both the sides. Take cube root on both the sides. Now this is what we're trying to find. The cube root of 13,824 is what we're trying to find. So that will come down as it is. On the right hand side, we need to get rid of this cube root symbol. So from 3 equal primes, 1 out. 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 Right? So now the product of the RHS. 2 2s are 4, 4s are 8, 8 3s are 24. So the cube root of 13,824 is 24, which means 24 into 24 into 24 is 13,824.
Ma'am, I put one doubt, ma'am. Can I ask?
No. 1 minute. Now I have to clarify something. I have answered the question, find the cube root of 13,824. But the heading is 13,824 a perfect cube? Give reasons. I'm sorry, children. Anyway, see, I didn't, take a look at the question clearly. No, I read it correctly, but now I just assume that we are finding the cube root of the given number. Okay, the cube root is 24. The working is all fine, but we are not asked to find the cube root here. We are not asked to find the cube root here. The question is 13,824 a perfect cube? Is it a perfect cube? Yes or no? Yes, it is a perfect cube. So what's your reason? That's all we have to write. We need not find the cube root of the number because it's not asked. I should have taken a look at the question again, children. I just worked assuming that it is like we did a question like this earlier, so I just continued like that. I'm sorry. The question is 13,824 a perfect cube? Yes, it is a perfect cube. Give reasons. Because every prime factor occurs in triples. The reason is because every prime factor occurs in triples. That's the reason. That's it. We don't have to find the cube root because that's not the question. The question is not find the cube root of 13,824. The question is this number a perfect cube? Yes, it is a perfect cube. What is your reason? Because every prime factor occurs in triples. That's it. So you need to just write this step. Yes, 13,824. 1 second. Is a perfect cube. 1 second. Since it can be expressed
as a product of its
as a very good as a product of
its prime factors.
Product of triples
Okay.
of equal prime factors. Because see here, now supposing 2 3s are 6, 6 5s are 30. Now what is 30? 30 is 2 into 3 into 5. Now this is also a triple. Triple is a set of 3. Triple is a set of 3. Now there are 3 primes here, no, 2, 3, 5, 3. So is 30 a perfect cube? No, because it should be, you should be able to express a number as a product of triples of equal prime factors, not prime factors, equal prime factors. If it is 2, 2 should happen 3 times. 3, 3 should happen 3 times. 5, 5 should happen 3 times. That's the difference between prime factors and equal prime factors. See, 30 is 2 into 3 into 5. And we have a triple of prime factors here. Triple is 3. A set of 3 is a triple. A set of 2 is a pair. A set of 2 is a pair. A set of 3 is a triple. So this is a triple. Triple, a product of triples of prime factors. No, equal prime factors. So it's not a perfect cube. 30 is not a perfect cube. So every word here is important. Yes, 13,824 is a perfect cube because it can be expressed as a product. Product is because we use the multiplication sign. Okay, product of triples of equal prime factors. Every prime factor occurs in triples. So it's a perfect cube. Yes, I think it was Anirudh. What's your question?
Ma'am, I wrote like the cube root of 2 to the power 9 into 3 square, ma'am. But I don't know how to divide 2 to the power 9 for like 2 cubed, ma'am. How to do that, ma'am?
If you have 9 pieces, how many triples can you make? 3, 3, 3, right?
Yes, ma'am.
Yeah, so basically you just have to divide the power by 3. Supposing it is 2 to the power 9, then how much will come out of the cube root? Divide the power by 3. 2 to the power 3 will come out of the cube root.
Okay, ma'am.
But for this answer, you should not be using the cube root symbol at all. Cube root symbol is used only if the question is to find the cube root of the number. Otherwise, this symbol should not come in the answer at all. You should not be using the symbol in the answer. You can use this symbol in the answer only if the question is this.
Okay, ma'am.
If the question is not about finding the cube root, you should not use that symbol. That symbol has no, no space in the answer at all.
I'm 1 minute, ma'am. I'm writing, ma'am.
Yeah. Please write down, all of you. Write the reason, what you see on the screen.
Done, ma'am.
Yeah.
Finished, ma'am.
Very good. Yeah. Is now see here, this number ends with 4. And we know that a perfect cube can end with any digit, right? A perfect cube can have any digit in its ones place or the units place. So now this number has 4 in its units place, and it happens to be a perfect cube. Look at this number, 2700. Now, if the number has to be a perfect cube, it has to end with 3 zeros, 6 zeros, 9 zeros. So the number of zeros, the number ends with should be a multiple of 3.
Ma'am, it is a perfect cube, ma'am, but you wrote like as perfect cube, ma'am.
Oh, yeah. Sorry. Sometimes when I prepare it in a hurry, I do go wrong. It's a perfect cube. Correct. Yeah. I'll correct that. Yes. Okay. So is 2700 a perfect cube? Give reasons. So here also, you should not be using the cube root symbol in the answer, because the question is not find the cube root. You're just asked to say yes or no. Is it a perfect cube or not? And write the reason. So this cube root symbol should not be used in the answer. Now you can see that the number 2700 ends with 2 zeros. So it cannot be a perfect cube. Because if it has to be a perfect cube, the number of zeros it ends with should be a multiple of 3. So a number ending with 3 zeros may be a perfect cube. Not that it is a perfect cube. Now 1000 ends with 3 zeros, and it is a perfect cube. 10 cubed is 1000. Now 2000 also ends with 3 zeros, but that's not a perfect cube. The perfect cube after 1000 is 8000, which is 20 cubed. After 1000, which ends with 3 zeros, the next number that ends with 3 zeros and is a perfect cube is 8000. Not 2000, 3000, 4000, 5000, 6000, 7000. No, they all end with 3 zeros, but they are not perfect cubes. Now 9000 ends with 3 zeros. It's not a perfect cube. So all numbers that end with 3 zeros need not be a perfect cube. But if a number ends with 1 0 or 1 0, 2 zeros, 4 zeros, 5 zeros, no, it cannot be a perfect cube. Because the number of zeros in the end must be a multiple of 3. 3 zeros or 6 zeros or 9 zeros or 12 zeros, 15 zeros, it should be a multiple of 3. So if a number ends with 2 zeros, it cannot be a perfect cube. But you cannot give that as a reason. Okay, so you have to go through the prime factorization procedure. We know it is not a perfect cube. But if it is a question like this, give reasons, you have to do the prime factorization procedure. But yes, you know it is not a perfect cube because it ends with 2 zeros. See, it can be a perfect square. A number ending with 2 zeros can be a perfect square. It need not be a perfect square, but it may be a perfect square. Okay, so like 100 ends with 2 zeros. Now again, a number ending with 1 0 cannot be a perfect cube, cannot be a perfect square also. Now 8790 ends with 1 0, right? Now this number ends with 1 0. It cannot be a perfect square, and it cannot be a perfect cube also. Because if it has to be a perfect square, the number of zeros in the end should be a multiple of 2. 2 zeros, 4 zeros, 6 zeros, 8 zeros, 10 zeros, and so on. If a number has to be a perfect cube, it should end with zeros and multiples of 3. 3, 6, 9, 12, 15, and so on. So a number ending with 1 0 is not a perfect square, not a perfect cube. 2 zeros may be a perfect square, not a perfect cube, but may be a perfect square. So this is 10 square. But 200 ends with 2 zeros, not a perfect square. 300 ends with 2 zeros, not a perfect square. 400 ends with 2 zeros, and yes, it is a perfect square. 500 ends with 2 zeros, not a perfect square. 600, not a perfect square. 700, not a perfect square. 800, not a perfect square. 900, yes, 2 zeros, and it is a perfect square. Yeah. Yes, Chibu. When I was talking all the while, you should have been listening to me and not working this answer.
Okay, ma'am.
Were you listening or working this answer?
Ma'am, both, ma'am. Ma'am, listening, ma'am.
Very good. How many say listening? Raise your hand. Both I don't want. I want only listening. Srijit, Harini.
Ma'am, I raised my hand, ma'am.
You were listening, Navneet. Okay.
Ma'am, what about both, ma'am?
Both எழுதக்கூடாதுன்றேன் கேட்டுட்டே
Single word. I too didn't even write a single word. Okay, ma'am. I can show you the proof.
Okay, very good. Okay, so Anirudh was writing and listening, not Navneet and Avnish. Okay. What about Dhanvin? No answer.
Both.
Both. Okay, I'll catch you both another day with a different question. And then I'll tell you the importance of listening only and not writing and listening. So not today. You're spared today. Yeah. Yeah, children, tell me. 2 how many times? Yeah, now I have to give you time to write. Work and tell me.
Yes, ma'am.
Write the question, do the prime factorization and let me know.
Ice cream.
Disable your mic. Srijit, disable your mic. Sorry?
Ma'am, I wrote 3, ma'am.
No, I said, always start with the smallest prime. It's not wrong to start with 3, but you start with 2. Now tell me with 2. You repeat the procedure starting with 2.
Ma'am, 1,350. After that, 675. And after that, 5 3 table, ma'am. 3 table. For that, 675. 6, 3, 2, 6. And 225. 225. 225. 225. In the hurry, ma'am. Sorry. 225. 9. 3 table. Ma'am, 75. Ma'am, 25. 3 table. And then 5 table. 5. And then again 5 table. That's it, ma'am. That's all. 3.
So now what's the next step? What should I write now?
Ma'am, 2,700 is equal to 2,700 is equals to 3 cube and 5 square and 2 square, ma'am. Ma'am, let 2 square into 3 square into 3 into 5 square.
No.
2 square into 3. 2 square into 3 cube, ma'am. 3 cube, ma'am. Square.
You must, because the question is it a perfect cube? You should write it in power 3. But if the number is happening only 2 times, you cannot write power 3. Then you have to write 2 only. You should try to write it in power 3. But these two happen only 2 times. So this is 2 squared, 3 cubed, 5 squared. Now tell me, is it a perfect square or not? I'm sorry. Is the number a perfect cube or not?
Not a perfect square, ma'am.
It's not a perfect cube. Why? Because?
Ma'am. And because?
Yeah. What's the reason? Because?
2 square and 5 square, ma'am.
Correct. You've identified correctly. But how do you express? Because 2 square and 5 square?
Yes, ma'am.
Sahasra, are you there? Sahasra?
Yes, ma'am.
Okay. So 2700 is not a perfect cube because the prime factors 2 and 5 do not occur in triples is the reason. The prime factors 2 and 5 do not occur in triples. That's the reason. Because every prime factor, when you factorize a cube number, you will see that every prime factor occurs in triples. If it is not a cube number or a perfect cube, every prime factor may not occur in triples. See, like here, 2 and 5, they don't occur in triples. So 2700 is not a perfect cube. So no, 2700 is not a perfect cube, not a perfect cube because the prime factors, 2 and 5 do not occur in triples. Right on?
Done, ma'am.
Okay.
Ma'am, I also got the same answer when I start with 3, ma'am.
Yeah, you will get the same prime factors, Srijit. You will get the same. Yeah. It's not wrong to start with 3.
Okay, ma'am. Ma'am, you said there's some advantage when we do it in order. What's that advantage?
You don't have to. Now, when you start with 3, or supposing you start with 7, you don't have to. If you start from 2, and then if it is not divisible by 2, then you proceed to 3. You don't have to check 2 again.
Ma'am.
But if you try randomly, you'll have to always check the others from the beginning.
Okay, ma'am.
Certain things we follow in order. Now, for example, on the label, mostly on the label, what is first? Your name. Then what? Class and section. And then the subject. And then the name of your school. Correct? Now, I don't know if labels now have school first and then say subject and then your name. So this looks kind of weird, right? School, subject, name, and then standard. What sort of a label is this? You understand what I'm talking about? Label. So we are comfortable when you look at something like this. Yeah, name, class, section, subject, school. Perfect label. This is a perfect label. This one is like, like so crazy. Name for school first and then subject. You don't like this. Yeah, but both give the same information, right?
Yes, ma'am.
Yes. That's all. Something like that here. So start with 2. When the number is no longer divisible by 2, then go to 3. Again, when it's no longer divisible by 3, 5. No longer divisible by 5, 7. So go in that order. Next one. Evaluate. Evaluate means find the value of. Find the value of. That's the meaning of the term evaluate. Meaning find the value of. So find the value of cube root of the cube root of 42.875. Now, there is a long division process to find the cube root of a number, but it's not a part of your syllabus. So to find the cube root of a perfect cube, we only have this prime factorization method in the syllabus. To find the square root of a number, we work it in two ways. You can use the prime factorization method or the long division method. Cube root, only one method we'll be learning, only the prime factorization method. So find the value of the cube root of 42.875. So using the prime factorization method, there is no other option. All right. I'll just get you started, then you can continue. Yeah, please complete this. Write the decimal number as a fraction. So it is cube root of 42,875 divided by 1,000. Because 3 decimal places, no? 1, 2, 3. 3 decimal places, so 1,000. It has 3 zeros. 1,000 has 3 zeros. This is how you write this decimal number as a fraction. Yeah, now complete this and let me know. I'll just come back in some time. Please work.
Ma'am, the answer is 3.5. Ma'am, the answer is 3.5.
Very good. Yeah, tell me the factorization of 42,875. Sahasra.
5 cube into 7 cube.
So 5 how many times?
3 times. Oh.
No.
8, then 5, 8, 7, 8,575. Then again 5, 1,715.
1,000?
1,715. Then again 5. Oh, sorry, 3. Wait, that's 7. 7, 343. Then again 749. Then again 7. Then 1.
Okay. Okay, so this is how we start. Now after this, so cube root of 42875 by 1000 is equal to cube root of, what's the cube root of, sorry, let me write this as the first step. Or now that you use it, you can directly write the step also. You don't have to write that and then repeat. I normally ask you to repeat, right? You can write the step straight away also. So cube root of 42,875 by 1000 is equal to cube root of 5 cubed into 7 cubed divided by 2 cubed into 5 cubed. So now this is nothing but, this one is nothing but cube root of 42.875, right? So you can just put that back. This fraction is nothing but cube, sorry, yeah, there's nothing but cube root of 42.875 is equal to, so from 3 5s, 1 5 out, from 3 7s, 1 7 out, from 3 2s, 1 2 out, from 3 5s, or you can even cancel this 5 cubed and 5 cubed, but I choose not to. I'll tell you why. So then 5 cubed is from 3 5s, 1 5 out. All right. Don't cancel the 5 and 5. So this is equal to 7 5s are 35 by 10. And 35 by 10 is 3.5. So when the denominator is 10, 100, 1000, it's easy to write the number in the decimal form by just shifting the decimal point. Otherwise, in this case, it's not going to be difficult. If you cancel 5 and 5, 7 by 2, 3.5. But in other cases, maybe you have to divide and find the decimal value. So you don't disturb the denominator when it is 10, 100, 1000, you don't disturb the denominator. Let it be 10, 100 or 1000 because you can easily put that fraction into decimal form. Only for that reason. Otherwise, the answer is going to be the same either ways. You can even cancel 5 and 5 here, or you can even cancel 5 cubed and 5 cubed here. You can simplify, right? You can cancel equals from the numerator and denominator. So you can cancel this 5 cubed and 7 cubed. So then you will get 7 by 2, 3.5. So it's all the same. It amounts to the same thing. 35 by 10, which is 3.5. So you may have some doubts, questions, please ask me. 3.5 into 3.5 into 3.5 is 42.875. Yes, children?
Finished, ma'am.
Any doubts? So
No,
to
ma'am.
find,
No, ma'am. No, ma'am.
okay, so to find the cube root of a decimal number, you have to write the decimal number as a fraction. To find the cube root, we learn only this method, the prime factorization method. We don't have any alternate method in our syllabus. Okay, so there's no choice. You have to work it by the prime factorization method. So write the decimal number as a fraction. Then factorize the numerator, factorize the denominator. The numerator is 42,875. Factorize that and factorize the denominator using prime factors only. And then write the factors in powers of 3 because you have to find the cube root in powers of 3, not 2, 3. Then from 3 equal primes, 1 prime out, 1 out. So like that, and you see the answer is 3.5. Yeah, so we understood that, the cube root, sorry, the cube. Oh, sorry, 1 second. We understood that a cube number is related to the volume of a cube. You saw that here, right? Cube numbers or perfect cubes are related to volume of a cube. So you see the question now. Yeah. The volume of a cube is 8,57,375 centimeter cubed. Find the measure of its edge.
Ma'am, the formula is the cube root of the volume.
Correct. Correct. Volume of cube is equal to 857375 centimeter cube. This is given. Now, edge of the cube is equal to cube root of volume. Or you can write that straight away. 1 second. You can just write that straight away. Edge of the cube is equal to cube root of volume. That is cube root of 857375. So find work the factorization of 857375. Find the cube root, and whatever is the cube root of this number is the edge of the cube. Yeah, finish this. Don't forget to write the question, children. Write the question and work the answer. Done, children? Shri Harini, can I get the answer from you?
Ma'am, I didn't complete that. Going to complete.
Okay, finish it and I want the answer from you. Let me know once you finish. Finish, Harini?
Yes, ma'am.
Yeah, tell me.
5.
5, huh?
Yes, ma'am.
13, 23, 33. Okay, 5. How many times?
1, 1, 5, 1, 4, 7, 7.
1, 5?
1, 5, 1, 4, 7, 5.
1, 4, huh?
Yes, ma'am.
How 1, 4?
Ma'am, I think it's.
Ma'am, is it 171475?
1, 7, 1, 4, 7, 5. So 5 ones are 3 remains, 7 are 35, 1, 2 remains, 4 are 20, 3 remains, 7 are 25, 2 remains, yeah, correct. 1, 7, 1, 4, 2, 5.
Ma'am, after that 34295.
3, 4, 2, 9. Okay. 5 threes,
Five.
2 remains, 1 remains, 2, 4 remains.
3, 4, 2, 9, 5.
Yes, ma'am.
Yeah, 2, 5. Then
Ma'am, then 6859.
6, 8.
59.
Okay.
Ma'am, after this, I'm not getting any number, ma'am.
Yes, ma'am. Till 13 I tried, ma'am. After that I tried.
Ma'am, I think so. It will go in 3 table. No, ma'am. In test of divisibility.
No, ma'am, it does not go with 3 table.
Test of divisibility did you do?
Okay, then that means it's 6059 only, 19 times. 1 second. I might have typed the number incorrectly. Just a minute. Please wait. 857375. Let me just check. 857375.
Yes, ma'am.
We have 6059. We don't have. Okay, see, I can. Let me just share this at this point. I'll correct the number, but listen to this. So now what is 10 cubed 1000? And 20 cubed is 8000. All right. 20 into 20 into 20 is 8,000. Now this number 6859 lies between 1,000 and 8,000. So its cube root has to be somewhere between 10 and 20. And it ends with the digit 9. So it has to be only 19. Because 19 into 19, see this table. Okay, so it has to end, see here, if a number ends with the digit 9, its cube also will end with the digit 9. And this number is what? 6859. 6859. It ends with the digit 9. So its cube root also should end with the digit 9. See here, 9 into 9, 81, into 9, 729. If a number ends with the digit 9, its cube root also will end with the digit 9. Okay, so then it has to be 19. There's no other choice. It has to be 19. So what is 19 into 19? Using my calculator. 19 into 19 is 361 into 19 is 6859. I'm getting it. So I've typed it incorrectly here. This one I've typed it incorrectly. 6859. I just explained. The number, I repeat, so it's correct. The number given is right. Here. 10 into 10 into 10. 10 cubed is 1000. 20 cubed. Listen to me. Don't continue working. 20 cubed is 8,000. Now this number 6859 lies between 1000 and 8,000. So its cube root should be between 10 and 20. And since the number ends with the digit 9, its cube root also will end with the digit 9. So then there's only one choice. Between 10 and 20, 19 is the only number that ends with the digit 9. So it has to be 19 cubed. So 19 into 19 is 361. Into 19 is 6859. So you should hit the number straight away like this. When you realize that the number is not divisible by 2, 3, 5, 7, 11, you're tired. So you should hit the number straight away. How do you do that? You should check between the two cubes between which this number lies. You must identify the two cubes between which this number lies. So this number 6859 lies between the two cube numbers 1000 and 8000. 6859 is between 1000 and 8000. And the cube root of 1000 is 10. The cube root of 8000 is 20. So the cube root of 6859 will lie between 10 and 20. That's one thing. And the other thing is the number ends with the digit 9. So its cube root also should end with the digit 9. Then between 10 and 20, 19 is the only number that ends with the digit 9. So we guess it should be 19 cubed. If it is not 19 cubed, if it is not 19 into 19 into 19, then that means the given number is incorrect. Because we are looking for a perfect cube number. This one should be a perfect cube. For this question, this number should be a perfect cube. Okay, so I worked 19 into 19, 361 into 19 is 6859. So it is 19, 361 times and 19, 19 times. 19 once. All right. Convinced, children? Understood? Please acknowledge.
Yes, ma'am.
Okay.
Done, ma'am.
Yeah.
Ma'am, can I tell the answer?
Yeah, what's the answer?
Ma'am, 5 cube into 19, 5 cube into 19 cube, and then in the end 19 into 5, which is 95.
Correct. Therefore, the edge of the cube is equal to 95 centimeters.
Done, ma'am.
Okay. So when the volume of a cube is given to you and you're asked to find the edge of the cube, you must find the cube root of the volume given. And it will be a perfect cube. The given number will be a perfect cube. And you have only this choice to find the cube root using the prime factorization method. You don't have any other alternative. If it is a decimal number, you'll have to convert that to a fraction and then find the cube root.